Ahmad Faris Rimazlan. I'm from FTMK, BITC S1G2.
My name is Chua Xingying and I'm from BITC S1G2.
Hello, my name is Noraisha binti Jaafar and I'm from 1 BITC.
Hi, my name is Shazaliana. I'm from FTMK, course BITC.
Program to be run in Qt-Spim, which is allowed user to enter 10 random numbers. After user enter the numbers, this program should be able to display A. The numbers that have been sorted in ascending order, the sum of the enter numbers. C. The average of the enter numbers. D. The median value for the numbers to Before we solving and move to the system solving problem, we need to know what is MIPS instruction format and how the system works. In this program, we combine three types of instruction format, which is R type, I type, and jump type to solving the current problem. All MIPS instructions are 32 bits long with 3 format instructions. As you can see, that's for R format, I format, and J format. What is 3 instruction format? Let's treasure it. Register type or R type is a contain all instructions that do not require an immediate value, target offset, memory address, and etc. Next is immediate type or I type. This includes instruction with an immediate operand, branch instruction, and load with store information. The last type is for jump type or J type. It consists of the two direct jump instructions J and JAL. Next, let's go to the data part. There are 5 stages of the data parts. First is for instruction fetch. Second, instruction decode and register file read. Third, execution or address calculation. 4 is the data memory access, and the last stage is for write back to meeting. Suggestion of full coding that we use to solving the problem. Common format of assembly language. You will have the data, the function for the system call, for the program to end, .txt. Quite similar to C++, where you can see the word with the red color is the C++ program. In the .data section, all string variables that we will use we declare here. Array also declare in this section that we will use. As you can see, the array colon dot space 40 is the array declaration. The dot space command tells the compiler to allocate space in the array, and the next number is show how much space you will allocate in bytes. One integer is called 4 bytes. So in our case, 10 integer, which is 4 times 10 is equal to 40 bytes. So we will allocate 40 bytes in the array. Next, the prompt arrange sum space dot colon average and median is the short variable that we will use in the coding to output the words we want. Example like please enter 10 numbers, arrange in ascending order, sum, colon, space, dot, average, and median. Backslash n is for new line. .txt and .globalman is a directive where it tells the assembler that the following lines are the source code of the program. .globalman is another directive. At start, at immediate, $T9, $T9 1 is for counting numbers that user input one by one. At immediate $T9, $T9 1 is equal to $T9 equal to $T9 plus 1. Next is followed by loaded immediate $V04 is to ask user to enter the number. $A0 prompt is also to ask user to enter the number. Loaded immediate mean load immediate. In this case, load immediate $V04 is command that tell the compiler we will pass a string value to $A0. By the way, $A0 is sweep command in MIPS. Next, syscall is for the system call. Or immediate $T3 $0 is for set sum to 0, which is equal to $T3 equal to 0 or sum equal to 0. Or T4 $0 is same as before. $S1 array is to set $S1 as an array.
The number read from $T9 into $A0. Line 30, load immediate value 1 as system call code for print integer. Line 31, call operating system to print integer value. Line 33, load immediate value 4 as system call code for calling. Line 34, load address that points colon buffer into register $A0, syscall. Line 37, load immediate value 5 as system call code for read integer, syscall. Line 40, store word. It will transfer value inside first register into second register that come after command. Line 41, we will add 1 this time, we will add 4, that means 4 byte for integer to go to next position in array. Line 42, $T9 equal to $T9 plus 1. This was the update for input counter. For line 43, this is for loop array where I equal to I plus 1. Line 44, branch not equal $T1 not equal to 10. It will go to looping until user enter 10 numbers. Line 46, load address that points array buffer into register $S1. Line 47, subtraction $T1 equal to $T1 minus $T. Line 50, branch equal $T2 9 con sorting. This was conditioned to check to continue sorting. Line 51, load wait. It will take value inside second register and store inside first register that come after command. It copy value inside 0 and store it inside $S1. Line 52, it copy value inside 4 and store it into $S1. Line 53, we'll add 1, this time we will add 4, that means 4 byte for integer to go to the next position in array. Line 54, this is update for loop counter. Line 56, branch less equal. If T3 is less than T4, it will back to sorting. Line 57, swap position to arrange if true. Line 57 and 58, to compare first value and second value. If first value less than second value, and jump to sorting and loop again. Line 59, branch not equal, $T2, 9 sorting. If T2 not equal to 9, it will back to sorting. 62, load address that points array buffer into register $S1. Line 63, we'll add 1. This time we will add 1, that means 1 byte for integer to go to the next position in array. Line 64, this is update for const sorting counter. Line 65, branch not equal, if $T1 not equal to 9, it will go back to sorting. Line 67, load immediate value for a system call code for arrange. Line 68, load address that points arrange buffer into register $A0 syscall. Line 71, load address that points array buffer into register $S1. Line 72, subtraction $T1 equal to $T1 minus
We are going to print out sorting. We load immediate value 1 to register V0 to print out sorting. Then the second line means move array to $S0. System call is to call the operating system to print the sorting value. Next, load immediate value 4 to register V0 to print string. The second line, loads address register @0 is for space line. This line is to update the position of array for the next loop. We will add 4 means 4 bytes for the integer to go to the next position in the array. And this is the update for loop counter. BNE means branch not equal. In this case, the program will continue to loop while the condition T1 is not equal to 10 is true. When T1 is equal to 10, then the program will exit the loop and continue to the next part. These are the declaration. Then we will go to the print sum. Print sum is for cout sum as you see in the console at the right hand side. Same as the previous one, we load immediate value 4 to register V0 to print string. Then the second line means that we load address $@0 for sum and it will cout sum colon as you see at the right side. Here we will calculate the total sum of all input number. In this line, load the value inside the array $S1 into $T5. This one we update the position of array for the next loop. This means T6 equals to T5 plus T6. We will store the summation value into T6. This line will repeatedly adding the value into T6 with the value from array. This one means for T1 equals to 0, T1 equals to 10, T1 equals to T1 plus 1. If T1 is not equal to 10, then the program will back to total and will continue to loop. Then, move the number from $T6 into $A0. We load immediate value 1 into $V0 to print T6. As you can see, the result is printed out in the console.
For these lines of code, we're going to display the average and the colon, which is this, the ASCII, and then in here we are going to calculate the average. We're going to assign the T7 with 10, and by divide this is the sum of all of the number, and we're going to divide them by 10. In this line of code, we're going to move the quotient of the divide to the S7, and in this line of code, we're going to move the remainder of the divide to the S6. In this line of code, we're going to use these codes to display the quotient of the divide, and here we're going to display the dot, which is here, and in here we're going to display the remainder of the divide in here. Okay, in this line of code, we're going to display the median and the colon, which is this, and in here we're going to calculate and place the position of the median. In here we're going to choose the 5th and 6th number of the user input. By doing so, we're going to add the two number and divide them by 2. And then we're going to display the quotient of the divide, which is 5. And then we're going to display the dot and display the remainder, which is 1. And this lines of code is used to end the program. That's all. So let's run the coding to get the output. We go enter the 10 numbers. And here is the simple output. That's all. Thank you.